Hi guys, so I hope you tried the student practice. If you did, your answer should be very similar to the two graphs I graphed in the last video. The only difference will be obviously instead of like 1/2 and 1/4, you'll probably have 1/3 and 1/9 and things like that. So just keep that in mind and obviously try to do it. So now I pose this question to you. 5 to the x power is equal to 7. And so based on what we know, if I do 5 to the 1, you guys would tell me that's 5, and if I do 5 to the 2, you'd tell me that that's 25. Okay, but what is 5 to the 7? Or, sorry, 5x. So what power do I have to raise x to get 7? So let's think about that. If I have 5 squared is equal to 25, then 5 to some power to what is equal to 7? Well, you can see right away that it must fall between 1 and 2. It looks like it's extremely close to 1, so maybe it's 5 to the, I don't know, 1.23 or something. I don't know. It's obviously some number. And it would be very nice if we could determine what that value is. Well, fortunately, that's what logarithms are for. If we use logarithms, we can use the base of the exponential and we can figure out what power it should be raised to in order to give us the other value, the 7 in this case. So what would happen in this case is I'd take the log base 5 of 5 is equal to log base 5 of 7. Okay, we still have that x there. And then I would move this x out to the front because there's a rule that says we do that. X times that. So we have x times log 5 of 5 is equal to log 5 of 7. And this turns out to be 1, so this is just x is equal to log 5 of 7. Okay, and so whatever this value is will be the exponent that x should be equal to give us the, x value for 5 to some power equaling 7. So with that being said, just know that if you're given something like this, 5 to the x is equal to 7, then what we do is we go log. Let me give you a more general form of this. We have a to the x is equal to b. Then what that translates to in logs is log a b is equal to x. Okay, so that is how you set that up, and that is how you go about conducting the transformation from exponential to logarithmic form, and that's very important. So make sure that you know how to transform that. Okay, with that being said, let's look, because I think you're more comfortable probably with logarithms. So let's do some examples of this. So if I say this is log base 2, so what this reads is log 2. 16 is equal to x. So let's transform that to exponential form. So it's this. So if you look, this to this power, so that's going to be 2 to the x power is equal to 16. Well, then x must equal 4. Okay. If I do the next one, log 25 and 5 is equal to x. Then I have 25 to the x is equal to 5. So 25 to what power is equal to 5? Well, we know that 25, the square root of 25 is 5. So then x is equal to 1/2. Okay, remember, x is equal to 1/2 is the same thing. So let me put it this way: 25 to the 1/2 is actually equal to the square root of 25. So remember that if you have to take pre-cal, it's very important, especially if you take calculus. So make sure you know that. You will learn it if you do not now. Next one, log 7 of 1 over 49 is equal to x. 7 to what power gives you 1 over 49? Well, that would be 1 over 2 again. Actually, hold on. Sorry, no, it wouldn't be 1 over 2. It would be... So we have 7 to some power is equal to 1 over 49. It would be -2. Sorry about that. Okay, and then finally we have log 2 of the 5th root of 2. Well, remember the 5th root is the 1/5 root, 1/5, so then that's what x is equal to. Why? Because we have 2 to the x power is equal to this 5th root, so 2 to the 1/5. Right, same thing. And so therefore we have x must be 1/5. Okay, obviously if we were in class I'd have you guys try these next ones. When logs are written out without a base, we consider them base 10. So keep that in mind. If I just write log 5 is equal to x, then what I'm saying is 10 to the x is equal to 5. Okay, so this is considered to be base 10 if there's nothing written there. That's just by default. Special cases, if we have log b to the x is equal to x. Well, that should be obvious because all you're going to do is you're going to take that, put it out in front like I did in the first example, and then you have log b of b, which is 1, so then x is equal to x. So whatever that power is here is your answer, and that's what you've seen also in this example here, even though it said originally 5th power of 2. Okay, because remember the 5th power is the 1/5 power. So let's graph some logarithms. Y equals log 2 of x. So this is y is equal to log 2 of x. If we do a t-table, x, y, I'm going to be more specific here. Logs cannot be 0 or less. You cannot have a 0 here because their domain needs to be greater than 0. Unless it's shifted. So this is not shifted. And the reason is because remember on our other graph when we had 2 to the x, it looked like this and it didn't go below into the negatives. So that's why the domain of this has to be positive, because remember they're inverses of each other, so the range on that becomes the domain here, and so you cannot use 0. So let's use 1. Let's use 2. Let's use 4. And let's look at these values. Log base 2 of 1. Well, what power do I have to raise 2 to get 1? That would be 0. So 1, 0. If I put log 2 of 2, what power am I raising this 2 to get 2? That would be 1. And then if I did log 2, 4, remember this is 2 to the x is equal to 4, so then x is 2. So let's go ahead and graph this. It's going to look like 1, 0, so that's here. 2, 1 is going to be over here. And 4, 2 will be somewhere over here. And it actually goes something like this. Okay. Now, domain. I said 0 to infinity a minute ago, and I'll explain more in detail why. We have range. That's going to be from negative infinity to infinity. Okay. Now, why does it work this way? So remember, if I do y equals 2 to the x, we said the domain is from negative infinity to infinity, and the range is from 0 to infinity. Okay. If this is for log base 2 x, then these domain and ranges have switched, because this, if this is f of x, then this is f inverse of x, meaning they're inverse functions, and therefore they switch the domain and range and you get your values swapped. Okay, so that's how that works. Now, how would a shift look here to make this domain different? Well, if I give you log 2 of x plus 2, then our h and k rules work. It would have to look more like this. And so how would this shift work? It would say h is equal to negative 2. So then negative 2 is our new shift. So we're going to go 1, 2. We have an asymptote this way. And so our asymptote is now at x is equal to negative 2. And therefore our domain is from negative 2 up into infinity. And our range stays the same. Okay, so there's that. Then let's look at log base 3. X minus 1 plus 2. Okay, so we have this, and so if we wanted to do this one, what is our vertical asymptote? Well, we say h is equal to 1. Okay, so then that means x is equal to 1 is our asymptote. So if we were going to graph this, instead of it being here at 0, it would be over here at 1. So we have this going on. And then all of our points are moved up too. So if I do, I don't know, we can't make this 0 here. Okay, so let's make that a different number. Let's make that 1. So if I put 2, here we go, x, y. So if I put 2, 3, and 5, I'm obviously doing that for a reason. I want this to be, if I do 2, that becomes 2 minus 1, which is 1. So that would be 0 here. So 2, 0 is a point. Oh, but there's a plus 2, so that would actually not be 2, 0. That would be 2, 2. Sorry about that. I forgot there's that 2 there. Darn it. Okay, so 2, 2. Sorry, this should be 2, 2. And then if I do 3, I put 3 here. That's 2. That's not good. 3 doesn't work, so I got to use 4. When I say it doesn't work, it does have a value, but you need a calculator to do it. So if I do 4, that becomes 3. So this is 3 base 3, which is 1 plus 2. So then this would be 1 plus 2 is 3, so 4, 3. And then obviously the next one I need to get is 9. So if I want 9, that would be 10. And 10 minus 1 is 9, so that's 2 plus 2, that's 4. So at 10, all the way over here at 10 is 4. And so your graph looks something more like that. It's the same shape and everything. It's just, notice it's shifted over. So if we look at the domain, it's from 1 to infinity. The range is from negative infinity to infinity, coming from down here all the way up to here where it goes towards infinity, and so on. So there are some other rules and things like that. Keep these in mind. So what does the first one say? It just says b to the 0 is equal to 1 in every case. We've talked about that. Log base b of b is 1. When you have the same thing next to it, it's 1 always. Log base 1 of, if they write log 1, that's obviously equal to 0. Why? Because that's 10 to the 0. Log 10 is equal to 1. Obviously, that's because this is 10. So these are basically the same rules. They're just with base 10. And then we have what's called a natural log. And a natural log has a base e. And e is actually a number that is equal to 2.71 something. It's like pi almost. It's irrational. And it has a special value. We use ln to represent when it's log base e. Okay, so that's all that means. And all of the rules are the same, and we'll get into the rules more in detail in the next videos to come. So I hope this is helpful, guys. Make sure you're doing homework. Make sure you're practicing. I hope you're all well. Take care.